So in the previous video, we found that after something like 3,000 epochs, so after 3,000 optimization steps, we found W0 and W1 were approximately 6.2. And we found that the bias, B, was approximately negative 2.6. And so you should imagine those as the values going into this this neural network function that we have down here. Usually neural networks will have a much more complicated formula than this, but it's built up by pieces very similar to this. It's just like a composition of things that look like this. And so part of the reason I wanted to try it for this simpler neural network, this like really small neural network, is because it's small enough that we can just see explicitly what's happening. So you can think of this as (6.2 x0 plus 6.2 y0 minus 2.6. Okay, that is the critical line. For example, and I wrote y0, but I should have written x1 here. And so, for example, let's try just setting equals 0. Hey, if this equals 0, well, sigma of 0 is 1/2. So this is what's called the decision boundary for this particular neural network. For most neural networks, it won't be a linear decision boundary, but in this case it is because it's such a simple neural network. So when the value of this thing here, this left-hand side, when that is strictly larger than 0, then we have y is estimated to be sigma of something strictly larger than 0. So that's something bigger than 1/2. So that's like where we would start predicting true. And conversely, if this was strictly less than 0, then we would predict false. And let's try to plot this. So we'll plot x0, x1. And you can think of this as, let me write it in a different color. I'll write it in red. You can think of this as x1 equals negative x0 plus 2.6 over 6.2. Okay, so I solved this thing here. I solved this, or this whole thing, including the equals 0. I solved this for x1. Okay, and so what does that look like? Well, the slope is going to be -1, and the y-intercept is going to be like between 1/2 and 1/3. So slope is -1. So it'll look something like this. Okay, this is the decision boundary. And let's look at our data points. Okay, this 0, 0 data point, or this 0, 1 data point. What do those look like on this picture? So the 0, 0 data point is there. The 0, 1 data point is something like that. And the 1, 1 data point is in that upper right-hand corner. And so you can see that 3 of these, okay, the three bottom ones here, they are all on one side of the decision boundary. And the last one with 0, 0, that's on the other side of the decision boundary. And that corresponds to a prediction of 0 for the 0, 0 input and a prediction of 1, a probability bigger than 1/2 for these inputs. Okay, and again, why do I sometimes say 1/2 and sometimes say 0? Well, if you plug in 0 to the sigmoid function, if you plug in 0 to 1 over 1 plus e to the -0, you get 1 over 1 plus 1, you get 1/2. So that's the 50-50 cutoff point, where on one side of this boundary, here it's a line. In general, it'll be something very complicated. On one side, it is a prediction of true, and on the other side, it's a prediction of false. So that's all I'll say in this video. Thank you for watching.